My name is Jesse. I am a Maze Guy, and this is Math with the Maze Guy. All right, so today I want to jump right into the discussion because I remember when I was a child, I used to like the idea of all these letters and numbers and coming out with one quick explanation. So I thought I'd talk about equations and letters and all that stuff and how they work out well in math, particularly the language of math. So the first thing you need to know, or one of the first things that I want to go over, is going to be how you write basic operations. And the four basic ones are going to be the add, subtract, multiply, and divide. So when it comes to add, the only kind of symbol you're normally going to see is going to be the plus sign. That plus sign means you're adding this number to that number. Later on, you might see this weird looking thing, which is the summation sign. Right now, you don't have to worry about that. Subtract is going to be your next one. And you're basically going to see that line. This minus that. There's one thing I'm going to go over before I go into the next thing, but subtracting is this minus that, 4 minus 2. You can't do 2 minus 4 because that's going to be a completely different answer. But one minus the other. Multiply. Now multiplication has a lot of symbols that we use. The one you might see now would be the x. Now later on that is not ideal to use because we use x in a lot of different equations. But right now you may see x. Another popular one are parentheses. This times this. Whatever's outside times whatever's inside. Another one is going to be a dot. We use a dot to be 2 times this. 2 dot this. That's multiplication. And then later you'll see that this to a certain number up here, a little number up here, which is called the exponent, is basically multiplication because it's this times this times this times this, whatever it says up here. We'll go into that later. And then there's divide. Now divide, we mainly will see that one right there. But we're going to see basically a line. This over this, whatever over whatever. Don't call these zeros, these are just blank spaces, because 0 over 0 is something that mathematicians and scientists debate all the time. And yeah, that's what we're going to see for division. Now, when it comes to letters, letters are any number you want them to be. Now, they're going to represent a lot of different things. Usually we use y and x, but that's for graphs. I am going to go into a little bit more of an explanation when it comes to letters as far as how we're using them in all 4 of these operations. But yeah, let me go ahead and erase this and I'll get to that. Okay, so I did want to explain how the letters are used in mathematics and the equations that we write. Letters are going to mean numbers. So whenever we're talking about letters, we know that there's something there, but we just don't know what it is at that moment. But we're going to go ahead and call it A or B or X or whatever you want to call it. But right now we're going to go ahead and call it A. We don't know what it is. Be aware that A and A squared are not the same number. A cubed, not the same number. Let's say A is 2. That means A squared is 4. A to the 3rd power is 8. They are not the same number. So, with that in mind, let's say I have A plus 2A's plus 3A plus A squared. And they tell you simplify that. You're going to say, well, that's not the same number, but these are all the same number. That means we got 1A plus 2A's plus 3A's, which is 6A's plus A squared. We can't go any further than that right now. I mean, we can easily factor out an A, blah, blah, blah. But right now, we can go there, and that's your simplification. Note, they are not the same number. So if we're adding up letters, we can only add up the letters that are the same. These are called terms, like terms. A squared is going to be by itself. So if we had another a squared plus 2a squared, then we can say, well, 1a squared plus 2a squared is 3a squared. So then it would be 3a squared over here. So be aware of that, letters and addition when we're dealing with letters. Now multiplication is a little bit different because now we don't know what these are, right? We know that they're different. We know that all three of them are different, but we just don't know what they are. But there is something we can say about these. A squared is a times a. A cubed is a times a times a. So if we want to do a times a cubed, we're going to look at it and say, well, a by itself, a times a cubed, a times a. We don't need this. We can easily do a dot because it's multiplication. Multiplication is just multiply it all out. That means this is equal to 4. So let's ask, what if we do a squared times a to the 3? That means it's a times a times a. Well, these are these two. And then times a times a. These are these 3. So that's 1, 2, 3, 4, 5. That means it's a to the 5th power. Easy way to do it is just add these up when you're multiplying. So math does require some memory, but you're just kind of breaking it down. In this case, we looked at it and we're like, oh, wait a minute, well, we can do it like that. So if we say b cubed times b, we know all we have to do is add these because we're multiplying, like I just said. So it's b to the 3, and there's an imaginary one because it's just b. They're not really multiplying it, it's just b multiplied by itself. So 3 plus 1, that's going to be b to the 4th. Okay? Multiplication, this is very handy when it comes to simplifying things, but you've got to realize multiplication and addition, there's something to that where you can move things around on one side of the equation, but you got to be careful because addition, a plus b, does equal b plus a. You can change it around. However, a minus b does not equal to b minus a. Don't do that, not subtraction. Multiplication, a times b does equal b times a. Division, no, a divided by b does not equal b divided by a. So those are some things that you really got to be careful with because it comes in handy. That's what leads you to that PEMDAS, which is our parentheses, exponents, multiplication, division, addition, and subtraction, our order of operations. So I'm going to erase all of this and I'm going to come up with some examples and talk about what we might be doing with those examples. Okay, so here I have some basic examples on what I was talking about and what we need to do to simplify and make things a little bit easier. So first off, we have this one, 2 times 3 plus 4. Now, I said we need to do the parentheses first, so 3 plus 4 is 7, times 2 is 14. So the answer to this is 14. Or we can do 2 times 3, which is 6, 2 times 4, which is 8, 6 plus 8, same thing, 14. This is just a different way to do it, but you will need to learn that later for equations. But how we use multiplication and how the parentheses is used, very important. If it's separated by a plus sign, you're going to need to do that. If it's not separated, if it's all multiplication, just multiply it all out. And that's what we're going to do here. 2x times 4xy. So we multiply the numbers first because we know what 2 times 4 is. 2 times 4 is 8. X times x is what? x, 1 plus 1, x squared. There's no y here, but there's a y here, so there's just times y. So this is going to be your answer, 8x squared y. We're just going to multiply it all out. And remember what I said about multiplying letters. If it's the 1x, x to the 1, x to the 1, x to the 2 is your answer. So this one over here is going to be kind of like what we've been talking about, but I didn't necessarily go over exponents. When we're doing exponents, anything inside the parentheses gets raised to the third power. And when we raise to a certain power, it's going to be this times this. So it's going to be a 2 times 3, which is 6, over b 1 times 3, which is b to the 3. That's going to be your answer. Okay, we don't have anything else we need to look at. There's all the a's are done, all the b's are done. This one over here, let's go ahead and start simplifying that one. Now we know what 4 times 2 is, right? That's 8. A squared times a, that's a to the third, right? 2 plus 1. There's no b, so let's just leave the b there. C times c is c to the 2, right? All over c to the 2, because we still have c to the 2. Now when it comes to division, we're doing this divided by that. 8 divided by 1, that's just 8. A to the 3 divided by 1, it's just a to the 3. B divided by 1. And I'm saying 1 because you can multiply 1 times itself and it doesn't change the number. So 2 times 1 is 2. 5,000 times 1 is 5,000. So multiplying it by 1 doesn't change the number at all. So A3 divided by 1 is A3. B divided by 1 is B. C2 divided by C2 is 1. We can put the 1 there, but we don't need it. Everything, whenever we have 1, it's there. So C squared kind of got rid of itself. This is going to be your answer right here. Now, the very last one that I put here is just going to be using the equal sign. So now, we're going to do what we learned here, and we're going to figure out what the letter actually is. Because it says there's an equal, it means we're going to say this letter equals this number. To do that, we're going to manipulate everything. We keep that equal sign. We're going to always bring that equal sign down. We want to keep it there. But we want to move all the letters to one side and all the numbers to another side. Luckily, right now, we only have one letter here. So let's do that. J plus 3j is 4j. So right here we have 4j's plus 2. Because we got rid of those two, and then we put the plus 2. We got 2j minus 3. And we still have a letter here and a number over here. So now we need to move one over to the other. I'm going to move this 2j over there and the number over here because I want to stay with positive numbers. So we're going to subtract 2j's from here. We're going to subtract 2j's from here. That's going to leave us with a minus 3 here equals, now 4j minus 2j is equal to 2j's, right? 4j's minus 2 of the j's, we get 2j's left. But we still have a plus 2 here. So now we want to put the 2 over here. We're going to subtract 2 on both sides. Now we got minus 3 minus 2 is equal to minus 5 is equal to 2j, right? Now, let me move it over here. Well, I'll move it right here because it's closer to me. But now we got 2j equals minus 5. If we want to get the j by itself, if we're multiplying, we're going to divide. We're going to divide by 2. Divide by 2 because 2 divided by 2 is equal to 1. So now we just have 1j, we don't need the 1, is equal to minus 5 over 2. And that's your answer. So I hope this helps with some of the equations. It gets really deep, but these are the basics. Dividing it, make sure we're subtracting. If we have a2, if we had an a down here, we have 2a's divided by 1a. it would look like that. A times A divided by A. A divided by A is 1, and you're left with just 1A. So the trick here when you're dividing is you're going to subtract the 2 minus the 1, and you're going to have 1A left. Later on down the line, if you have a negative number as an exponent, another quick little tidbit is if you have a negative exponent, A to the minus 2, that actually is equal to 1 over A to the 2. Okay? So I hope this helps. If you have any questions, leave them on the comment and I'll try to get to them on the next show.